Good evening. Today we are going to discuss about how to improve the performance as well as security of wireless sensor network by using fine-grained distributed data access control. This is the concept. We can see in the web. So our objective of wireless sensor network is we need to protect the sensitive data. So actually we are implementing the concept of wireless sensor in mission critical application. That is maybe the military application or a hospital environment. In that case, we want to protect the sensing data. The next one is we need to improve the lifetime of sensor. So for that, we are going for some cryptographic technology as well as some clustering concept. Then first one is introduction about wireless sensor network. Like our college environment, we are dividing the storage system into two categories. First one is centralized approach and next one is distributed approach. In centralized approach, each sensing data are directly transmitted that particular data into the central plane. That is, that may be called as server. If anything happening failure due to some hardware failure or due to some power failure, then maybe the system may fail. In that case, we need to protect the data as well as we need to access the data from the servers. At the same time, if sensors sending the data, at the same time sometimes due to some failure, the server may be failure. So in that case, we need to transfer the data from sensor to server. It may lose the data due to the situation the server is not available. This is the main drawback of centralized servers. But it is when comparing with distributed environment, the accessing is very fast because each data are stored in the centralized mode. Next one is distributed approach. In distributed approach, actually we are dividing the single server into more than one part. We place it into many parts. If any server may become some failure, in that case we can manage with some other remaining servers. This is the concept of distributed approach. It also having some drawbacks, because the server want to communicate within that particular environment. In that case, it may create some overload, that is overhead. It's a drawback of distributed approach, but actually we are using the distributed approaches for in the sensor environment. The next one is access control. First, we are going to see what is access control is. What are all the attributes available in the access control list. First one is what is access control list. It stores what are all the users available in the particular sensor. Each sensor having some set of users as well as some security level for that particular user. For example, consider in our college environment, we are having a lot of system. In that system, we are using the browser. In that case, we are dividing the three categories. First one is admin, and next one is staff level. Then third one is student level. Each one differ from other level. Like this, the sensors also having some high configuration. In that case, it also having some set of users as well as users authorizing levels. Okay. So, but in the access control list is having some what are the users available and what is the authorized level of the particular user, the identification for particular user. But here it is only possible to implement in the wired network. But we are here discuss about wireless network. It is not possible because it is deployed without any physical protection. So any the sensor may be hacked or the sensor may be theft by any users. So in this case, we can't implement the access controls. For that, we are going for cryptographic concept. In cryptographic technology, there are two major categories there. First one is symmetric key cryptography. The next one is public key cryptography. In symmetric key cryptography, the both encryption as well as decryption using the same key for encrypted as well as decrypted. That is called symmetric key cryptography, as well as we can call as private key cryptography. The next one is public key cryptography. In public key cryptography, both sender as well as receiver using some different key for encryption as well as decryption. But comparing to symmetric key cryptography, public key cryptography is security, because both sender and receiver using different key. No one knows the other's key. That is called the public key cryptography. Okay. Then next types of sensor. There are two types of sensors available. First one is passive sensor and active sensor. In passive sensor, it needs energy level from external resource. like our satellite antenna. Okay, solar panel. We can get the energy from solar panel. That is called passive sensor. Next one is active sensor. In active sensor, we can provide its own resource, like our battery. So we can give the energy level for particular sensor. Based on that energy level, it will go. If any energy is lost, after that we need to restore or we need to increase that particular energy level as well as bandwidth. That is called active sensor. Then application, where the sensors are implemented. First one is the main applications of sensors are mission critical applications. The next one is medicine, robotics, manufacturing. So even though our real time environment like mobile, a car, we are having some small such of sensors, but comparing to mission critical application that having high performance as well as high costly sensors. Next, traditional system. In traditional level, the sensing data are directly transmitted to the access point. In that case, each sensor directly transmitting its own data to the access point. It consumes more bandwidth. So the lifetime of sensor will be reduced. That's the drawbacks of using the particular technique. The next one is fixed secret key. In fixed secret key, each sensor having some set of files. In that file, it having some unique fixed secret. If anyone hacked or compromised the particular sensor, they can be able to retrieve the particular that key. So they can be able to easily hack the sensing data. So we need to lose the entire data generated by the particular sensor. That is the drawbacks of using fixed secret key concept. The next one is fixed time and phase single phase transmission. That means we are dividing or we are giving some unique time for each sensor. If it reaches maximum level, what we are defining that particular sensor. If it reaches maximum level, in that case, it will transfer the entire data to the server. In that case, anyone hacked that particular means they can able to know the entire detail about particular data. That is the drawbacks of fixed time and phase data transmission. So to avoid this concept, we are going for some recent technology. First one is dynamic clustering. Dynamic means runtime. We can able to cluster the data at any situation based on the boundary level as well as based on the bandwidth level. Okay, that is called dynamic clustering. The next one is dynamic secret key. First, initially we giving some files to the each sensor. After performing some transmission, after that we can able to change to remotely. That is called dynamic secret key. The next one is providing fine-grained data access point. It's a main technique to protect the data. Okay, so you can see one way. Dynamic clustering. Before clustering the sensor, we need to select the cluster head, that is leader for particular cluster. So based on the energy level of each clustering, we can select the cluster head. That's the first concept. Then after selection of leader, we can group the sensor based on the distance. So that particular leader will send some message, that is called recruit message. It having the identification for the particular sensor as well as the energy level of that particular leader sensor. Okay. Based on that, the client sensors will check whether it is corresponding identification number as well as bandwidth level. If comparing to client bandwidth, if it is high means, then automatically that particular client will join with that particular cluster group. So after that, the leader will act as a cluster group. It may going to as a client. In both client as well as head may act as both client as well as sensor head. Okay. So this is concept of dynamic clustering. The next one is dynamic key selection. How we are selecting the dynamic? That is a runtime. Actually, we are selecting based on the three phases. First one is key pre-distribution. In this case, first we are initially creating some dynamic. Initially creating, the user is given by some set of unique number, or it may be any alphabetical, or it may be any symbol. That is called pool. That is like a memory pool. Okay. After that, we are dividing the single pool into more than one part. Each part will be assigned to each sensor. That is, it stores its corresponding key to each sensor. That is the concept of key pre-distribution phase. The next one is strategy discovery, after storing the key into the each sensor, it will communicate with neighbor sensors whether the corresponding key is available to the nearby sensor. If it is matches with nearby sensor, then it can be able to communicate by using some protocols like ECC algorithm also available. Then public key, a lot of public key cryptography is available. By using some other technique, it can be able to communicate with nearby sensor. The next one is for key establishment phase. After communication with the nearby sensor, it can enable to denote what are all the details can share with nearby sensor, as well as what are all the details can share with through cluster. These are all the phases of how we are defining or how we are selecting the keys. The next one is fine-grained data access control. It's one of the technique to protect or to improve the performance of sensor. First one is collision resilience. That means we can avoid the collision while sensing the data. By using this technique, we can avoid the collision during the sensing of data. The next one is sensor compromise resilience. If anyone compromises the particular sensor, means in that case we need to remove that particular sensor from the corresponding cluster. Otherwise, they can be able to compromise the remaining sensor also. So we need to remove the particular compromised sensor. The next one is backward secrecy. In the access control list, we are having some set of authorized user. In the authorized user, sometimes some situation they may be relieved from the particular user. So we need to revoke the user. Otherwise, they may act as some illegal activity. They may do some illegal activity after leaving from the group. So we need to avoid that user also. That is called backward secrecy. We can add any new user, as well as we can revoke any user from the list. Then it is a technique of data storage. Actually, in the traditional system having single phase transmitter. That means each data is sensed. After that, it will directly transmitted to the access point. In that case, if anybody hacked that particular data, means they can be able to understand what is we are sensing the particular environment. So for avoiding that, we are dividing the single phase into more than one phase. That is, first we are dividing the single data set into stages. That is called B. After that, again further we are dividing the stage into more than one phases. Based on that phase, we can encrypt by using the corresponding key value. And first one is we need to calculate the current phase key by using previous phase value. So K T minus 1, that is the key for previous phase. The key will be applied into the hash function. After that, it will calculate some function. It will generate some key. That is called K key. That is current key, current phase key. The next one is in the sensitive data also divided into more than one phase. Each phase is decrypted by using the phase key. That is, D is denoted the current data. Then by using K D, we can encrypt the value D. Then after encryption, it will generate the data item. After that, it will store into like V phases of the corresponding data. Then time. What is the phase stage as well as phase? After that, the decryption value. Then finally, it will erase the previous key because we have a current key, so that we don't need to maintain the previous key. So it takes some memory. If we are maintaining the previous phase key, it takes some memory as well as it consumes some value. So we need to avoid that. So for that only we are removing the previous phase value. So we have new one. For next phase, we can use the current value for calculating the next one. This is the how we are storing the data. Then after that, by using the data storage, we can access. First, for example, if user want to access the phase V. So in that case, user J sends the request to I need the phase value of V, that is V1 for accessing the data. In that case, it will check first whether the corresponding user is authorized user or not. Okay. If it is authorized user, then it can allow to access the data. Otherwise, it won't allow because we are having some certain users to this. The next one is after allowing the user, it will send the data like usage, that is corresponding which users need to access the data. Then EV, that is encrypted value. Then decryption. The EV is the corresponding user's encryption key. Then DKT is the corresponding decrypted. By using the EV, we can decrypt the data. So after that, we can get the original value. Okay. This is a concept of how we are accessing the data from sensor. Then last one is user revocation. If any user want to revoke from the particular list, or the user maybe want to delete, or the user may want to some other user need to add with some other list. So in that case, we can revoke at any time. So that is the concept of dynamic key distribution as well as dynamic user defined log. Finally, I need to conclude that if we are choosing the area of sensor, we need to protect the data as well as we want to increase the lifetime of the sensor. So we are having lot of technique, but in that case we can't be able to implement in the real time. So we can use a simulation to check whether the corresponding algorithm or technique